review the stuff that we talked about before. We're going to hit 3, 4. And then, like I said, review Monday, test on Tuesday. If I said I want you to draw me a graph of a cubic function that only has one intercept, one x-intercept, one root. Are you with me? What could you draw a picture of? You could draw a picture, hopefully, if I just asked you to do this, you would draw a picture of something like that. We have talked about how cubic functions have this kind of shape, yes? No. And how many times does this touch the x-axis? Yes? All right. If I asked you for a cubic function, that's not the only one, by the way. That's not the only one. You could have one that looked like this, because cubics are allowed to do that. Cubics are allowed to do that. But still, do you see this the hook right here? It didn't come back far enough to hit the x-axis, did it? So how many times does that still, how many roots does that still only have? With me? This one would probably be the graph of something that had the multiplicity of 3. Remember we talked about the other day where one root counts 3 times? See how we have one root counting 3 times? This one, because of this right here shape, I'm going to say that it has one real root, and what do you think the other 2 are? The other 2 are the imaginary. Do you see the difference between when you have the imaginary versus when you have the product of multiplicity? Okay? All right. What if I said I want you to draw a cubic function where we have 2 roots? You're going to have to draw it coming from the up, right? From the bottom. You with me? And we're going to have to make a loop. But what happens when I make the loop? I can't go below the x-axis, because if I go below the x-axis, what do I know about odds? It starts down. It has to end what? So I know I have to go back up. What's the problem with this one? Why doesn't this work? There's 3. That's not what I asked you to draw. Are you following me? So if I went like this, I'll have to be very careful. And when I start to loop back down, I make sure my loop only touches right there, kind of like the vertex of the little parabola. And then that 1, 2, it hits only 2 times. That would be a graph of a cubic function that only has 2 roots. Yes? All right. And finally, we already did the 3 one. I don't think I need to do that again. If I wanted to do something that looked like 3, it would have been right here, the one that I messed up on 2 on purpose. Good? Little review for what we've done so far. All right. So let's go to this example. Oh, it does work. All right. So this data represents the population of a rare and dangerous frog. Kind of like what I look like. In order to better understand the glass frog's fertilization habits, scientists have performed a study to recorded the average number of frog eggs over a span of 44 months. So here we go. This is all their data. With me. This is all their data. This is the data plotted on a graph. Do you see where it says right here? It says that is the y equals. That's the equation of this graph. Notice x is to the what power? X is to the 4th power. What kind of function would this be? We had quadratic, we had cubic, and we had quartic. Very good. It's a quartic function. So, what is the domain and range of this study? What is domain really? Which I know that we have a hard time with, but we've heard these words for a long time. So it's about time to start knowing what they mean. What does domain mean? Domain means, what are all the x's? What are the possible x's? So if I go back up here and I look, my domain is going to be my x. Do you see right here, my x goes right along this axis, correct? So what is my x's are my number of months. You with me? So I look up here. What is the number of months? What does it go from? Okay, so my domain, the way that you write this, there's a couple different ways that we can write this. One way is to write it like this, where you say it goes from 0 to 43. Do you notice how I did these things that look like brackets? That's because it includes the number 0. Let's say it went all the way up to almost 0, but it didn't include 0. Do you remember those things called inequalities? Where you could get, like, if you say x is greater than 5, does it start at 5? Would 5 work for that example? X is greater than 5. Would 5 work? Is 5 greater than 5? No, it's not. So if I was doing that kind of graph, you have to do parentheses. Because parentheses means it does not include the number. So if I said x is greater than 5, I would go 5, comma, and to infinity. And I'd put a parenthesis there. Notice I put a parenthesis here and a parenthesis there. You cannot include 5 because if x is greater than 5, it does not include the number 5. So to show the difference between including the number and not including, we put a bracket versus a parenthesis. Do you see the difference between the two notations? This means yes, 0 is a possible number. It's used as one of my x's. 5 is not included. It's not used as one of my x's. But some number like 5.000001 is possible because it's 5.001 greater than 5. Yes, so it would work for this number. So I can get as close as I can to 5, but I can't get right on 5. It won't work. You following me on these things? All right. Now, what is the range? The range is going to take a little bit more time because you're going to have to look at all these numbers right here. And you're going to have to find the what? You have to find the biggest and the smallest. Someone do that? Let me check and make sure you're right. What's the smallest? 108.4. We have 108.4 and 15,966.9. That is correct. Does that make sense? Would I use brackets or would I use parentheses? What does parentheses do? Include the number or not include the number? Does not include the number. Are these numbers included that we are referring to? Yes, so it would be a bracket. You would put a bracket. Tell me those numbers again. So this, let me go back for a second. This is the domain. What's the difference between domain and range? Domain is all the x's. Range, it refers to the y values. So my range would be, what was it? 108.4 and 15. Okay? So that would be the domain and range. Explain what the domain and range represent in context of this problem. That means, what was the x talking about? The months. So what does this tell you? They started at, 0, yes? Yeah. And then they went all the way to 43 months. Okay? That's how many months that are represented in this data. What is the range? All the y values. Yep, but what is it talking about? Eggs. So what was the smallest number of eggs that they ever counted? 108.4. What was the most eggs that they ever counted? Was the 15,000. So we know that if I went out there and I studied that population, I'm probably going to get a number between here. Because they studied it for 43 months, right? So if they studied it for that long, that's probably a good indication of how many eggs are going to be there if I just went out there in the wild today. says the next one. What is the domain of the and range of the function? The function is referring to this. This guy right here. That is the function. Is there anything that is x is not allowed to be? Technically, I know this sounds weird, but technically, could I put a negative in there for an x? Yes, I could. Could I use this to predict how many eggs were back in 2010? Could I use this function to predict that? Yes, and if I wanted to do that, my x would probably have to become what? Negative. And so this function would continue. I can't do it. This function would continue like that, up and down, still going backwards. So I could see what happened. So in my real life, my real function, which is this, okay? In my real life, what is x allowed to be? That's what it's asking here. What is the domain and range of the function? Well, this can go really from negative infinity, meaning x can be any number, all the way to negative infinity, which means it just keeps on going forever, to what? Could I use this to predict the future? Yeah. So where would this go to? Infinity. To positive infinity. With me on that? Now, what would be the range of the eggs? In this, they're saying that in this, they're going back to this function, and they're actually plugging stuff in, and they're figuring out that it's different. It's a lot different. It goes from a negative big number all the way to positive infinity. Not worried too much about that. Are we getting this idea, though? Domain, range? Yes? Okay. At what month in the study were the least frog eggs observed? Which month had the smallest one? 7. You should be able to look at the data and find the smallest one. If the study lasted for 50 months, how many frog eggs would there be according to the function? Okay. Where would you plug that in? What does it mean to be 50? It says if it lasts for 50 months, how many frog eggs would there be according to the function? When I go up here, do I notice that it doesn't continue? What is this right here, though? The formula, how they found this curve. Are you with me? So what could I do if I wanted to see when it's 50? What does 50 really represent? Say it louder. 50 really represents my x. When I want to know something, what have I been begging you all year long? If you want to know what y goes with this x, what can you do with that x? And all you have to do is take 50. It's going to be a pain in the butt, but this is the expectation that you guys are able to do now. This is where I've been telling you, this is probably the part that we are getting wrong on test, and you're going to have to practice this on your own. Positive, negative numbers, adding and subtracting, order of operations is probably a 6th grade skill, guys, and we are messing up royally on that. If you need to see me after class to help fix that, I stayed after with some people and we talked about things that we need to fix. I can't do that in a class of 25. I can't go over each and every little skill for everyone. But the gist of this is you would take the 50 and you would plug it into here, right there in that x. And what would you do with that 50? What's the first thing you would do? 50 to the 4th power. And then you take that big massive number and times it by this decimal. You would then take 50 to the what? 3rd power and times it by this 20-something. You would take 50 to the 2nd power times it by this, and 50 times this. And then at the end, you would add, subtract, and divide, or whatever, add and subtract all those numbers together. And that would get you your prediction. Do you understand how we were able to do that? Now, is this going to be exact data? No, because this curve is doing what? It's doing an average. It's predicting. It's saying, you know what? It's kind of like the line of best fit, but it's not a line. It's like a curve of best fit, right? Because you can see even the data here doesn't fall perfectly on the line, but is it a good idea of how many eggs are going to be out there? Yes, and that's all we're looking for with math. We're never going to be able to predict, for the most part, we're not going to be able to say, this is what it's going to be. Exact. But we can do a really good prediction, and based on that prediction, we can say, yeah, that's a good idea to do this. No, it's not a good idea. Yes, these animals are flourishing, and they're starting to get better. Or, no, we need to do something before we kill all these animals off. We have those kind of programs nowadays. Yes. All right. Do you see what happened? Do you see anything weird on this graph between any months?
35 and 40 goes below 0.
Isn't that weird? Did you have that really? No. Does that happen sometimes in math where you have some kind of a function is describing something that is not possible? Because does this equation know that it's talking about real life? Does it know that it's going, you know what, I'm not allowed to go below 0? Does it know that? So what do you have to do when you're interpreting something like this? You have to realize that in order for me to keep this curve so I can predict later on, I've got to write it down there. But in real life, could this happen? What's the lowest amount that we could have? 0 eggs. Frogs can't be like, hey, I borrowed some eggs from next month, so got some negatives for this month. That doesn't happen with eggs. Yes? With me? Okay. Let's roll. Flip over to the next page. 265. All right. Absolute maximum. Absolute maximum. We talked about this. I kind of did this. Absolute maximum means there's an absolute highest value that the graph reaches. It will never go higher than this. What kind of functions do you know will not ever have an absolute maximum? Okay, once they go infinitely up. What kind of functions have to go, no matter what way they start, have to go up sometime? Say it louder, someone said it. Not parabolas. Odd. What do I know about odds? They start down, and then they end up. Are you with me? Does this graph ever have a highest value it can reach?
No.
What do I know about all my odd functions? If they start down, they end going what? If they start up, they end going down. Well, I don't care whether it happens on the left side or on the right side. Do you see this thing never ever stops going up? So is it ever going to have an absolute maximum? No. What are the only types of graphs that can have absolute maximums? Evens. So the only ones that can have it. What do I know about absolute minimums? Same thing. The smallest value and the only ones that could possibly have those are evens, because odds are going to change direction. They start up, they end going down forever. They're never going to have a lowest point that they hit. With me? All right. Let me see where they talk about. So this is another important part. The set of absolute maximums, absolute minimums, the relative maximums, the relative minimums may be referred to as extrema. The extrema are also called extrema points, or we're not even going to do that, extremiums. So here we go. Do we realize that this is a type of fourth degree, which we call a what? Quartic. Okay? They call this a quartic. How many extremas does this one have? Remember, extremas are relative or absolute maximums or minimums. So let's look at this one. What does this one have right there? What type of minimum? Because now I know I got two different types. This is an absolute minimum. How many does it have? All right, what is this? It's got, well, but they're on the same, but yes, it does have two. It's got two absolute minimums, and it's got a relative maximum. So how many does this one have? See what you can do on the rest of these. Real quick, try to fill that in. All right, so here we go. This one, you should have realized that this has 1, this has 1, 2, yes? And this one has 1, 2, 3, 4. This one actually has 0, I'm sorry. That's my fault. That one actually has 0. That's where I messed up. I was looking at that. That's funky. That has 0. Yes. Right. These are relative. Absolutely. Yeah. Absolutely. These are relative because this thing goes on forever. So it doesn't have an absolute maximum. It's got a relative, meaning if I only looked at this piece of the graph, like I cut this part off and I cut this part off right there, and I said, oh, well, between, here and here, it's got a highest and it also has a lowest. So yeah, that's relative. All right, let's go quickly through this one. How many does this have? It's got 1. How many? How many? Do you guys see the pattern here? What degree was this to? Do you see it was to the 6th degree? What are the possible, because these are all the possibles of 6th degree if you've noticed, what are the possible extremas that it can have? 5, 3, and 1. What is 6 minus 1? And then didn't you go minus 2 to figure out all the possibles? Let's look right here. What's 5 minus 1? 4. Minus 2 to get all the possible extremas. Are you with me? All right, let's use that then. You say you're with me. What if I had something to the 9th degree term? What are the possible amount of extremas, which we know are relative or absolute maximums and minimums? If I have the 9th, what's possibles? No. Remember, it was 1 minus, and then we start going by 2s. So 8, 6, 4, 2, or 0. So, if I'm doing this, can I just start to describe a possible 9th degree? Like, can I make up one on my own? So it could look like this. Ready? 1 extrema, 2 extrema, 3, 4. Could I keep going down forever right here? Yeah. No. How many possible extremas? 1, 2. I'm sorry, I'm only at 3. 1, 2, 3. I'm only at 3 extreme. Is that one of my possibles here? Why else does that make sense? What way did this thing start? Down. Can it end down? Why? Because it's a odd degree. Are you with me? Could I turn this thing back up and just keep on going forever up? Yes, because that would be 1, 2, 3, 4 extremas. Is that possible? Yes. Could I keep going? Yeah. So we got 1, 2, 3, 4, 5, 6, 7, 8. Is that a possible graph for this type of 9th degree term? Yes. Yes, ma'am. Just subtract 1. So 18 minus 1 is? That's not more. Yeah, don't make it. It's 17. Now go down by 2s every time. So 15, 13, 11, 9, 7, 5, 3, 1, done.
So it leaves us
Because, huh? Yep. Yep. What do we know about for evens? What does that tell you? It has to have one because why does that make sense? If I have a parabola, right? It's got one extreme, right? This would be a what, by the way? No, it would not. It would be an absolute what? Maximum. Because we're referring to y. How high can this thing go? How are we doing? Okay? Here's some possible charts that they're talking about. But I really wanted to get to... I think we've made a lot of these connections here. Alright, this is great. Consider the graph right here. This kind of puts everything together that we've talked about this whole chapter. Some investigatory, I don't even know how to say it. Investigative, how do you say that? How do you say that stupid word? We're going to do some investigating. That's how you say that crap. Alright, so we're going to do some investigating here. Like that. Do you see this right here? Based on my end behavior, what type of graph do you know I have?
positive.
Someone said odd. Someone said negative. End behavior. Facing down, facing up. Starts down, ends up. What do I know this has to be? Odd. Because it starts and ends a different way. Has to be odd. Are you with me? Now, since I know it has to be odd, is the a value of this function positive or negative? Well, I look at my chart, or I have to memorize it because it's not going to be on the test for me. I have to go, okay, which odd started down and ends up? And my a is what? Look at your chart. Flip back. Flip back. It's in 3-2. It's in 3-2 that we're going to this. This is scary to me. I know my a value is positive because I look at my chart and my chart says, my four-thing chart says, if x is going to negative infinity, I know that my y is going to negative infinity. And I know if x is going to positive infinity, then y is going to positive infinity. And that's when my a is positive and my n is odd. Well, I know that my n is odd because it ends different way. It's facing different way. And I know a is going to be positive because it starts down and ends going up. So I know my a value out there would have to be positive. When I refer to a value, I mean that number in front of the x to the whatever power this function is going to be. The next question, is this even or odd? We already just discussed that. This has to be a odd function. Now, can this be a cubic function? Yes or no? How do I know this cannot be a cubic function? No, cubic is odd. 3 is odd. Because what? Someone said there's 4. What are you referring to when you say there's 4 what? Do you see how there's 1, 2, 3, 4 extremas? Can a cubic function have 4 extremas? How many extremas can a cubic function have? Nope. 2 or 0. Remember, you subtract. We just did that. You subtract 1 and go down by 2 every time. We just did that. So that's another issue. We've got to be able to recall information I just taught you. We just went over that. So this cannot be no, because too many extremas. State the domain. What is domain? What did I just ask, or what did I just tell you domain was? No. All the x's. Does this thing ever stop going to the left? No. Does this thing ever stop going to the right? So this domain would be negative infinity to positive infinity. The range. What would be the range? Does this thing ever stop going down? No. Does this ever stop going up? Hold on. Alright. So, I want you to finish this, and I want you to do for homework number 8. That'll be good. Finish number 7 and do number 8.